Hello everyone, welcome back to our channel Geomatics Engineering. Here we learn and explore the things related to geomatics engineering. So today in our lecture we will talk about traversing in land surveying module. So before starting this lecture, I must say that if you have joined our Telegram group, then there I have already sent question series regarding land surveying, and if you didn't join right till now, then go and join that group because we are giving questions and we will also provide answers in upcoming days. So keep updated by joining Telegram group. So let's starting our this lecture video over traversing. First, what is traversing? So traversing is nothing but network of survey lines. Means if I am plotting multiple survey lines in my map or plan, so this is called traversing. Measurement of those survey lines and their angles is called traversing. In traversing, mainly two types of measurement is done. One is linear, length of lines, and other one is angular. These two measurements are done in traversing, linear and angular. We used to measure the angular measurement also, and we used to measure the linear measurement. And with help of this linear and angular measurement, we make a network of survey lines. For example, see here A, B, C, D, E. AB lines, BC line, CD line, DE line. Similar, and if our traversing started from some point and end to another point, then it is called open traverse. Means it is not completing a loop, it is not having same end point and start point, then it is called open traverse. And if our traverse is such that it is started from some point A, B, C, D, E, F, and again end at same point A, then it is called closed traverse. There are two type of traverse, one is open and another one is closed. So this is about little discussion on open traverse and closed traverse. Let's move further. What type of computations we do in traversing? Just remember, traversing is nothing but network of survey lines, and it is measured by using linear and angular measurement. Instrument can be used chain surveying, compass surveying, theodolite, plane table surveying, etc. Now let's move. Computations in survey. Computations in traversing are computation of latitude, computation of departure. Let's see what these are. Okay. I am drawing a line, this, for example, OA. OA is my line. So if this is our meridian, north, south, east, west, the projection of this line OA, on north-south axis or north-south line is called latitude. You can say projection, you can say shadow. The projection of line OA on north-south axis is called latitude. How we will calculate that? As I have said, in traversing we measure linear measurement like length. Also we measure angular measurement, theta. So using this L and theta, we can measure the latitude as L cos theta. Latitude is equal to L cos theta. Okay. Now further, if for example this line latitude comes in the direction of north, this line latitude comes in the direction of north. For example, there is another line OB here, OB. Now latitude of this line will be in the south direction. This one will be in the south direction, this much. This is the latitude of OB. So the latitude which is in the direction north, the latitude which is in the direction of north is termed as northing. Keep in mind, the latitude in the direction of north is called northing. and the latitude in the direction of south is called southing. These are two terms only representing latitude. And northing is taken positive, value of northing is taken positive, and value of southing is taken negative. So if you have forebearing of a line and if you have length of the line, you can calculate the northing and southing both. Now moving further. Similarly, just like latitude, if I am taking projection of line, on east-west axis, this is north, south, east, east. If I am taking projection of line on west-east axis, then this is called departure. This is our forebearing, this is length of the line, OA line is this. This one is the departure, projection of line on the west-east axis. This is called departure. So we can calculate departure as departure L theta from north, so L sine theta. Okay, now just like in latitude, if departure is in the direction of east, then it is called easting, and if it is in the direction of west, then it is called westing. And easting is taken positive and westing is taken negative. Value of westing is taken negative. So in this way we calculate departure and latitude. So this is our traverse A, B, C, D. This is a closed traverse starting from A, then B, C, and then D. So I am going to measure the latitude and departure here. Let's see. For example, I am taking north direction is this and upward direction is north, downward direction is south, this is east, this is west. So similarly for here also it will be there. So now easting, let's check for departure only. Easting will be this much length will be easting. I am representing it AB. This much length will be easting in this direction. This much length will be easting. Okay, so I am considering it positive. Again, if I am taking this line BC, the easting of this line will be departure easting plus BC. This much will be the departure of line BC. If you want to calculate, then calculate. This is the forebearing, this is the length, you can calculate. Now I am calculating for DC and BA. For DC, this much will be the CD. For CD line, this much will be the departure. This much will be the departure, and this is in the direction of west, so I am consider it is as negative DC. Now again for AD, DA, again this will be the DA. This is CD, this is CD, this is DA. So you can see here for departure we are going first in this direction and reaches C, farthest point. Started from this direction A and reaches C, farthest point, and now again we are moving back in this direction and reaches A. Then we can say that our total displacement is 0. Total displacement is 0. Similarly, if you will do this for latitude, you can see it also here also, that for example this is the latitude of line AB. We move up, then we move down, then again down here up to D, and then again up to A. You can check it also. For example, I am representing latitude with help of red pen. We move up to B, up to B. Then we move down up to C, up to C. Then again we move down up to D for line DC. This is the latitude of line CD. Then again we move up for line DA, here to EA. So our total displacement is net 0. So similarly in case of latitude, similarly in case of departure, our total displacement is 0. That's why we call that for a closed traverse, summation of latitude equal to 0 and summation of departure equal to 0. Okay, understand that we have calculated latitude with help of L cos theta. We have calculated latitude with help of L cos theta and departure L sin theta. Departure L sin theta. L sin theta. If you are calculating it for a closed traverse, then the all lines latitude summation comes up to be 0 and the all lines departure summation comes to be 0. Then we will say that your traversing is right, otherwise it is wrong. Okay, let's move further. This is about computation in traversing for latitude and departure. Now there are some extra computations, other computations like independent coordinates and dependent coordinates. Let's understand that. For example, this is our line OA, then AB, these are the line O, A, B. If I say that coordinates of A, x comma y is with respect to this origin 0 comma 0, 0 comma 0, coordinate of x comma y is with respect to origin 0 comma 0, then this type of coordinate is called independent coordinate. Means it doesn't depend upon any other point. But if I say that coordinates of B is dependent upon coordinates of A. For example, x1 is equal to x plus A, y1 is equal to y plus B. For example, I am just giving example. So our coordinate of x1 and y1 is with respect to this A. Then we can say that these coordinates are dependent coordinates. Means these are dependent on x. These are dependent on the coordinates of A. So it is very simple that if your coordinate does not depend on any other point, if your point coordinate does not depend on any other point, then it is called independent coordinate. If it is depend upon any other points, any of them, then it is called dependent coordinate. It is very simple. Now moving further, calculation of missing data. How we can calculate missing data? So we have already seen that in closed traversing, summation of latitude and summation of departure comes to be 0. We have already seen that in closed traversing, summation of latitude and summation of departure comes to be 0. A, B, C, D. For example, I have length of A, L1, length of B, L2, length of CD, L3. For this line, I have length and bearings also. This is theta 1, for this theta 2, for this theta 3. I have bearing also. We don't know anything about line DA. So what we will do? We will calculate the all latitude values for all lines, departure values for all lines. For example, line AB, latitude value will become L1 cos theta 1, departure L1 sin theta 1. Similarly for BC, L2 cos theta 2, L2 sin theta 2, CD, L3 cos theta 3, L3 cos sin theta 3, L3 sin theta 3. And for dA, we don't know the value of dA, so we are assuming it x and y. So by doing summation L equal to 0, we can calculate x, and by doing summation departure equal to 0, we can calculate y, and y is nothing but L4 sin theta 4, x is nothing but L4 cos theta 4. So by doing y by x, you can calculate tan theta 4. From there you can calculate theta 4, and if you get the theta 4, just by putting in this equation, you will get the value of L4 also. So in this way you can calculate missing data with help of traverse C. Now moving further, closing error in traverse. Okay, this is, we have already talked about that summation of latitude and departure is 0. We have already talked about that summation of latitude and departure is 0. What if summation of latitude doesn't come equals to 0? And what if summation of departure doesn't come equal to 0, or any one of them doesn't come equal to 0? Then we say that there is some error. Then we say that your traversing is having some kind of error, and this error is called closing error. And this error is called closing error. So this is summation of latitude and summation of departure of a closed traverse is always 0. If any case of closed traverse, if the summation does not come to 0, that means our closed traverse have some error. The last point is not meeting the first point. That means your last point you have taken is not meeting the first point. Is not meeting the first point. Here you can see here is not meeting the first point. The last point is not meeting the first point. That means in your traversing you did a wrong traverse. It is not a closed traverse. It have a error of this much length. It have a error of this much length, and this length is represented by E, called as closing error. So how we will calculate E? If summation L doesn't equal to 0, if summation D doesn't equal to 0, then E equal to under root of summation L square plus summation D square. Summation L square and summation D square. In this way your E comes out to be, this is your summation D and this is your summation L. So in this way you calculate E. You can also find the direction of E also with horizontal axis or vertical axis. For example, with horizontal axis I am taking theta, then tan theta will be summation L and summation D. You can calculate direction of the E also. So just keep in mind that our magnitude of error, closing error is this, magnitude of closing error is this, and direction is this. Direction is this. So in this way we calculate closing error. In traversing, closing error plays a very important role. It tells us about your traversing is wrong or right. And there are also several methods for removing closing error. We will see them. So next, that is process of removing closing error. So after closing error, removing of closing error is known as balancing of traverse. Means we are balancing our traverse, we are removing the closing error came in our traversing. This can be done by different methods like Bowditch, transit, axis and graphical method. In this module we will see Bowditch and transit method, which we will see in next lecture. Till then what we have learned, I am summarizing it up here, that we have seen that traversing is network of survey line. Traversing is network of survey line. Then in traversing we have seen open and closed traverse. in open and closed traverse. Then we have seen computations. In computations we have seen latitude, of a line, that is L cos theta. Departure of a line, L sin theta. Keep remember that theta is the bearing of the line, four bearing of the line in WCB system. Don't take QB system. Okay, if in question QB system is given, then convert it into WCB, then measure your latitude and departure. And for next we have learned that for closed traverse, our summation L equal to 0, summation D equal to 0. For closed traverse, summation L equal to 0, summation D equal to 0. And with help of this, we can calculate missing data in our traversing. Then after this, if summation L and summation D not equal to 0, then it cause an error, that is called closing error, and it equals to E, that is E equal to under root of summation L square plus summation D square. So this much thing we have learned in this video, and after that balancing of traverse we will see in next video. Till then, if you like the videos, then subscribe our channel and do comment in the box so that we can see that who are seeing our video seriously and targeting GATE this year. Also join our Telegram group, link is in the descriptions. Join that group and solve the questions we are giving there. After traversing, a lot of question will come there. Already from surveying, I have sent question related to bearings, fore bearings, back bearing, calculation of error due to local attraction. So all these questions I have already sent there. So go and check them, and also join our channel for betterment of yourself. So till then, bye bye and best of luck.